So what we have in the question that in the expansion of this, prove that the coefficients of a raised to the power m and a raised to the power n, they are equal. So we have to find out the coefficient of a raised to the power m and a raised to the power n, right? So first we will focus on this one, then we will focus on this one. Now, you know that the final power in the question that you have is m plus n. And I want this m plus n. First, I want this as m and then I want it as n, right? So it means when I want m plus n as m only, I have to remove this n. Clear? And when I want m plus n as n, I want to remove m now. Then, so please focus on the question. You just have to focus on the question. That's it. So let's move to the next page. First of all, we'll write the question. And the question is, let me change the color now. Just a second. Yeah, it will be. So the question is 1 plus a raised to the power m plus n. This is the question that you have. Now we have to find out the coefficient of a raised to the power m and a raised to the power n. Now, you know that what is the formula, the general term formula that you have of the expansion, that is TR plus 1, that is equals to NCR, a raised to the power n minus r and b raised to the power r. So what is a here? A is 1. A is equals to 1. And what is b? B is equals to a we have. And what is n? N is the final power that we have in the question. Now let's take n. Let's take r. Let's take r as equals to m, right? So let's take it as m. So fit in the formula that you have. So it will be t m plus 1, that is equals to m plus n c. What is m? R. So this is case 1, right? So what is r? R is m. A is what? 1. 1 raised to the power m plus n minus m. And what is b? B is equals to a. And what is r? R is equals to m, right? So tm plus 1, that will be equals to m plus n c m. 1 raised to the power something is 1 only. So we will just not take in it. And multiply a raised to the power m, right? Now, so what is the coefficient of a raised to the power m? This is the coefficient. Coefficient is whatever you have in multiplication. So this will be the coefficient of this. So if I will solve it, so let's solve it. So you have to use the formula for the combination. So combination formula is m plus n factorial divided by m factorial and m plus n minus m factorial. So what will be the final result? M plus n factorial, m factorial, m is cancelled with n, multiply n factorial. So this is the final coefficient, that value you have, right, in the question. Now, so this is the coefficient of a raised to the power m. Now, when I want a raised to the power n, so what I will do, I will take case 2. So let me change the color. So the color I will take as, okay, I will take blue. Now, case 2. I'm just changing here only. When I will take case 2, so please save this one. Okay, we have to save this one. Now, case 2 is when r is equals to n. When r is equals to n, so everywhere I have to put r as n only. So the case 2 will be when r is equals to n. So n, and minus n, and a raised to the power n. So this will be n. And the power here is a raised to the power n. So the coefficient of a raised to the power n is this one. So let's sort it out. When I will solve it, let's see what is the result. So the result, the question is this. Let's open the formula for the combination. So m plus n factorial divided by n factorial multiply m plus n minus n factorial. So m plus n factorial, n cancel out. So n factorial multiply m factorial. So see, this is, what is the coefficient of a raised to the power n? It will be this, means when I opened it, so the coefficient of a raised to the power n is this one. And the coefficient of a raised to the power m, that case 1, that is this one. They both are same. So we have proof that the coefficient of a raised to the power m and the coefficient of a raised to the power n, they both are equal, right? So that's that. So thank you, everyone. Thank you so much.